This is part of lesson 9.2. We're going to talk about special right triangles, the first of which is called a 45-45-90 triangle. Before we get into that, we're going to talk about some radicals, some square roots. So the simplest form of a fraction does not have a square root in the denominator or the bottom of the fraction. So we have to do something called rationalizing the denominator. To do that, we can multiply it by something that's equivalent to 1, because if you multiply by 1, it doesn't change its value. So the 1 that we're going to multiply by is the square root of 2 over the square root of 2, because anything over itself is 1. The reason we do that is because now on the bottom, right, we still have the root 2 on the top, but the root 2 times root 2 on the bottom is really the square root of 4. And the square root of 4 is a nice number. The square root of 4 is just 2. So the root 2 is going to stay on the top, but the bottom, which was root 2 times root 2, turned into a real 2. So we're going to do a little shortcut for this. We're going to divide the numerator and the denominator, the regular number by the square root, and then we're going to move the square root to the top, and we'll reduce that division if it's possible. So let's see what that means. For the first one, 24 over root 3. So we're going to do 24 divided by a real 3, and bring the square root of 3 to the top. So 24 over 3 does reduce. That turns into 8. So my answer would be 8 root 3. This is a check-in problem for you to try. Answers are posted on Classroom. Pause now if you'd like. For example 2, I'm now dividing by something that doesn't go in evenly. So I'm going to do 21 over the 2 and bring up the square root of 2. So I can't reduce 21 over 2, so I can leave it like that. So I could write it like this, where all of that's on top. I could write it like this, where it almost looks like we're saying 21 over 2 times root 2. Or if you really wanted to turn it into the decimal, you could, and that would be my answer. But this will probably be the way that I write it. So here's a check-in for you to try. Pause if you like. Answers are posted on Classroom. This one's a little different. Now it's not about the rationalizing denominator, but it is something to do with radicals that we want to discuss before we get to our actual problems. So we looked at it happening here. We had a root 2 times a root 2, which turned into a 4, root 4, and then we were able to take the square root of the 4 to get the 2. That's going to happen every time I have a radical times itself. So a radical times itself is the same as saying that number squared. And that happens when we have that, those cancel. So this is really just 2. So when I'm doing 15 root 2 times root 2, the root 2's are 2. So 15 times 2 is 30. If you want to say 15 root 4, actually do 2 times 2, but then you have to know you're changing the root 4 into a 2, and then you get your 30, that's fine. It's just an extra step. So here's a check-in for you to try. Pause if you'd like. Answers are posted on Classroom. So now we're going to get to the actual point of all that, because we're going to talk about a special right triangle that's called a 45-45-90 triangle. And it's named that because the angles in the triangle are 45 degrees, 45 degrees, and 90 degrees. This has to be isosceles because the two angles are congruent. That means two sides are congruent. And we're going to call those legs. So the legs are congruent. I'm going to label them with L's. The side across from the right angle is the hypotenuse. So I'm going to label that with an H. And we're going to have a formula. First of all, we already know that the two L's are equal. So if we want to write that down, we can. But the other thing that's always going to happen in every single 45-45-90 triangle, the hypotenuse is going to equal the leg times the square root of 2. So these are the two formulas we're going to use for 45-45-90 triangles. Every problem I get, I'm going to label with the two L's for the legs and the H for the hypotenuse. And every time, I'm going to write my equation out so that I can solve it. So for example, for A, if this is where the right angle is, that's your H, and the remaining two sides are both L. So since L is equal to L, then x would be equal to 8. And that's it. There's no other work to do to get x there. The other one, though, we're going to have to use the h equals L times the square root of 2. And I'm going to substitute each of these pieces in. H was really y. L was x, but it was also 8, so I'm going to use the 8. And it's times root 2. 8 and the square root of 2 are not like numbers, right? This is a whole number, this is a square root number. So we can't do anything to them. They stay as they are, and we're done. That's how long y is. We don't want any decimals replacing square roots in this section. All of our answers should either be a whole number, a decimal bit like a 0.5 that didn't have to be rounded, or we will have a radical in our answer. Here's example 4b. So again, here's my right angle. So opposite that is my hypotenuse. The other two sides are both legs. So x and y will be equal to each other. So I only have to solve for one of them, and that'll give me the other. So we're going to make our equation. H equals L root 2. I'm going to plug in 5 root 2 for H. I'm going to plug in either x or y for L. And the rest of the formula was L times root 2. Oh, I said I was going to plug in x. There we go. So right now, x has a root 2 with it. It's x times the square root of 2. To undo multiplication, we can use division. So I'm going to divide both sides by the square root of 2. Root 2 over root 2 cancels out. And over here as well, root 2 over root 2 cancels out. So I'm left with 5 equals x. And because the L's were equal, we can also say that y is 5. So here's some check-ins for you to try. Pause now. The answers are posted on Google Classroom. Example 5. All right, across from the right angle is our H. This is an L and an L. So we're going to start with L equals L. So x equals 3 root 2. Nothing else to do for that. And for our other formula, H equals L root 2. I'm going to plug in y for my H. I'm going to plug in 3 root 2 for my L. And I still have another root 2 in the formula. So this will look a lot like example 3. Square root of 2 times square root of 2 is 2. So this is 3 times 2. So y is 6. Here's a check-in for you to try. Pause. Answers posted on Google Classroom. All right, example 6. Right angle makes this our H. Other two sides are both L. I'm going to set up H equals L times the square root of 2. So 10 equals, I can pick x or y. Let's say x times the square root of 2. To get rid of the square root of 2, we're going to divide on both sides. It cancels out on this side, but there's nothing to cancel out on this side. So this is where we're going to use our little shortcut. We're going to take the 10, put it over the 2, and bring the square root of 2 to the top. And I'm going to look if this can be simplified. So 10 over 2 does go in evenly. It's 5, and we keep the square root of 2. And since my two legs are equal, we can also say that y equals 5 root 2. Here's one for you to try. Pause. Answers posted on Google Classroom. Example 7. Crossing the right angle is our H. We have an L and an L. So I'm going to set up H equals L root 2. So that's 19 going in for H equals either x or y. Let's say x root 2. So again, we're going to divide both sides by the square root of 2. It goes nicely on this side, not so nicely on this side. So we're going to do the 19 over the 2, bring the square root of 2 up. And I can't reduce 19 over 2. It doesn't go in evenly, so I could leave it like that. I can also call it 9.5 root 2. But again, I'm leaving that as a fraction, and since the L's are equal, y is also equal to 19 root 2 over 2. Here's a problem for you to try. Pause. Answers posted on Google Classroom. So example 8 says find the exact area of the square. So a square we know has all sides congruent and has right angles in the corners. So this is a 45, 45, 90 triangle. Both of these sides are the legs. And the 10, which is across from the right angle, is the hypotenuse. So if I want the area, I want to do length times width, which means I need to know what these sides are. So I'm going to set up h equals L root 2. So 10 equals x root 2. We've already seen these numbers happen once before. Divide by the square root of 2 on both sides. So 10 over 2, bring up the square root. So this is really going to be 5 root 2. So the length and the width of my square are both 5 root 2. And since area is found by multiplying those, we're going to do 5 root 2 times 5 root 2. When I want to multiply something like this, I can only multiply like pieces. So the 5 times the 5 is 25. And the square root of 2 times the square root of 2 is 2. So my area is 50, and the units were in feet, so that would be feet squared. Here's a problem to try. Pause. Answers are posted on Classroom. The last example, the perimeter of a square is 28 inches. Find the length of the diagonal. So if we sketch out what they're describing, we know we have a diagonal in a square, so that's going to be part of a 45, 45, 90 triangle. The diagonal is what we don't know. I do technically know the lengths of the sides. If every side was equal, let's call each one S, and all four are equal because it's a square, then S plus S plus S plus S, or 4S, is equal to the perimeter of 28. So if I divide both sides by 4, each side is 7 inches. So now I'm going to get rid of these, and I'm going to replace them with 7s. We have a leg, a hypotenuse. We'll do h equals L root 2. So x equals 7 root 2. And that's it. 7 and root 2 are not in common. Can't do anything. So 7 root 2 inches is our answer. This is the final try problem. Answers posted on Google Classroom. And that is the end of 9.2 with the 45, 45, 90 triangles.